So radical, we're multiplying radicals now. We did adding, subtracting. Now we're getting into multiplying. I have the rules there for you on your paper. You need to understand that it's similar to like when you're adding fractions. You have to have a common denominator when you add or subtract, but when you multiply, you don't. Same idea here. You don't need like radicals. Where you do for adding and subtracting, you don't need like radicals for multiplying. So we're just going to multiply. Like 5y, 4y to the third, just going to multiply. It's going to be radical 20 y to the fourth. Okay, that comes out to radical 20. And now it's just simplifying, which we've done. We've already done something. So you should be able to do this by now rather quickly, hopefully. 20 is 4 times 5, and then radical 4 is 2, so that's a pair of 2's. So that comes out to be 2. And then y to the fourth, you know, y, that's 2 pairs of y's, so that's y squared. And that leaves a leftover radical 5. So 2y squared radical 5 would be your final answer there. So here I have a coefficient in front, 3 and 2, so that's just going to be 6. And then we're going to multiply the insides. That's going to be 24x to the 9th. And of course, I need to simplify. Now it's a cubic root, so you got to be a little careful here. 24, I'm just going to do this off to the side. 24 I know is 2 times 2 times 2 times 3. That's 8 times 3. And then x to the 9th is x, 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 x. All right, so I have 1, 2, 3, and then I have that. All right, so I have a 2 times a 6, I have 12. 6 times, this is 1, 2, times the 6 is 12. I have 3 x's, so x to the third. That's all coming out, and I have a leftover 3. I have a leftover cubic root of 3. So 12 x to the third leftover cubic root of 3. Multiply. Now it's monomial times a binomial, and we're going to get to binomial times binomial down here, obviously. Radical 2 times radical 3 is radical 6, and then minus radical 4. Radical 2 times radical 2 is radical 4, but you guys should realize, you're going to start to realize that when I have a radical times itself, it ends up being just that number because square root of 4 is just 2. So this is radical 6 minus just plain old 2. And then I wouldn't leave that as my final answer. I would want to switch it around and write the radical at the end. That's the proper way to write your radical binomial. Negative 2 plus radical 6 would be your final, the way to write that. All right, so distributive property again here. I have 10 radical 3 plus 2 times 2 is 4. And then radical 3 times radical 3 is radical 9. I wrote it as radical 9, but again, radical 9 is just 3. So again, radical 3 times radical 3 was really just 3. All right, so 3 times 4 is 12. 12 plus 10 radical 3. Again, writing the radical at the end. Here I have 1 radical 5, and then radical 5 times radical 5 is just 5. We're gonna kind of cut out that step. You should be able to realize that by now, because radical 5 times radical 5 is just radical 25. Square root of 25 is 5. All right, 3 and 5 is 8, and then combine my like terms. 4 radical 5. We don't add the radicals. You don't add the radicands. Okay, you keep those the same. This one is a radical squared, or a binomial squared, so you really have to understand what that means. When you square something, it means to multiply by itself. So 1 minus radical 6 squared is 1 minus radical 6 times 1 minus radical 6. 1 times 1 is 1. 1 times negative radical 6 is negative 1 radical 6. And then I have the same thing in here, negative radical 6 again. That does not cancel to 0. And then radical 6 times radical 6, negative times a negative is a positive. Radical 6 times radical 6 is just 6. So I get 1 and 6 is 7. And this here, be careful. It's a negative 1 radical 6 and a negative 1 radical 6. That is negative 2 radical 6. All right. Here I have radical 3 times radical 3, which is 3. I have radical 6. I have another, so out here I have radical 6. Here I have another radical 6. And then here I have 2, just 2. 3 and 2 is 5. And then this, radical 6 plus radical 6, it's not radical 12, because that's what you were thinking. Or maybe you weren't. But radical 6 plus radical 6 should be 2 radical 6. That's 2 radical 6. It's like an apple plus an apple, 2 apples. A radical 6 plus a radical 6, there's 2 radical 6s when you're adding them. Radical x times radical x, that's just x. And then outside here I have 4 radical x. And then these on the inside here, I have 4 radical x again. And then 4 times 4 is 16. So now I get x plus 16 plus 8 radical x. And that's all I can do. I can't simplify any more than that because I don't have like terms. 7 times 3, 21. Minus 7 radical 5y. Here I have plus 3 radical 5y, and then minus 5y. Radical 5y times radical 5y is just 5y. All right, so like terms are only here. So I have 21 minus 5y, and then I have minus 4 radical 5y. This combines negative 7 plus 3 is negative 4, and the radical 5y just comes along for the ride. Keep the radicand the same. This one here is a little different, though. This is not like a binomial times a binomial. This is really just a single radical times a single radical. It almost belongs in the earlier example, but I wanted to kind of make sure you see how it is different from this. Compare, after seeing these, how you go back to this, and it's different. It's a radical times a radical. So what's a radical times itself? What's a radical times itself? Well, what's radical 5y times radical 5y? It was just 5y. So a radical x minus 5 times a radical x minus 5 is just what? X minus 5. That's it. That's that easy. Nothing to do. All right, now we're going to get into conjugate radicals. You already should know what conjugates are. Earlier in the course, we talked about conjugates, and like, for example, x plus 3 has a conjugate of x minus 3. And those multiply to x squared minus 9, right? If you multiply that out, see how it's only 2 terms and not 4? Because there should be 4 if you're distributing. Well, it works the same with radicals. So radical a plus radical b, radical a minus radical b. That would be the conjugate. And then vice versa. That's all this is saying right there. Example 4 just wants the conjugate. 3 plus radical 4, 3 minus radical 4. This would be negative radical 5 plus radical 2. You just change the sign in the middle. You don't change that one. Just the sign in the middle would make it a conjugate. And this one would be radical 6 plus 2 radical x. It's that simple. Okay, that's finding the conjugate. Done, done, done. Just finding the conjugate. Why are we doing this? Well, because we have this special multiplication property with conjugates, just like we did. X plus 3 times x minus 3 became x squared minus 9, and you just get those 2 terms. That's going to happen with radicals as well. Take a look. Radical 3 times radical 3, that's just 3. Radical 3 times negative radical 2 is negative radical 6. Here we have plus radical 6, and then here we have minus 2. So it's 3 minus 2. 3 minus 2 is 1. And then this right here is 0. I get that 0 pair. So instead of 4, I really only have 2, and then they combine. 3 minus 2 is just 1. That's it. Here, radical x times radical x is x. And then this is minus 2 radical x. And this is plus 2 radical x. Look at that again. Look at that. And then 2 times negative 2 is negative 4. So this again is a 0 pair. This is a 0 pair as well. 0 pair here, x minus 4. You just get x minus 4. That's it. So you only get 2 terms instead of 4. Why am I making a big deal about this? Well, you're going to see in our next lesson why conjugates are important. Okay, so when you hear me talking about conjugates in the next lesson, think about this. They play an important role in division and rationalizing the denominator, which we do in lesson 24. I will